Hello my dear students, once again welcome back to your online class. So in today's video we will be continuing with the second part of the first chapter of your physics textbook, that is the force. So today we will be discussing on few of the topics like the principle of moment of force, the center of gravity, and also the rotational motion, in which we will learn about the centripetal and the centrifugal force. So the first is the principle of moment of force. So what does it tell? Like whenever a object is balanced, that means under the balance condition, so suppose if this is a fulcrum at O, okay, so if I suspend two load at the two ends A and B, okay, so it's very clear that this beam balance will be perfectly horizontal only when the weight or the gravitational pull at A and B will be equal. So it is clear that at the point A, so the force acting or the moment of force is in this direction, so which is a clockwise direction, but at B it is a anti-clockwise direction. So when will this beam balance be a perfectly horizontal? When the clockwise movement will be equal to the anti-clockwise movement. So that itself is the principle of moment of forces. So which tells us that under a balance condition the clockwise movement will always be equal to the anti-clockwise movement. So now second important topic is of the center of gravity. So what is it? It's a center of gravity. So now what is the center of gravity? The center of gravity is an imaginary point which may lie within the body or even outside the body, such that the sum of principle of movement of all the particles of which the body is made up of is algebraically 0. So understand that. So let us consider one object which is made out of number of particles, say A, B, C, D, E and many more, or more precisely I can write this one as mass M1, M2, M3, M4 and so on, and last is Mn. Okay, so it is made out of n number of particles. So now I consider an imaginary point somewhere within the body O, such that if I find the and let the distance of M1 be R1, M2 be R2, M3 be R3 and so on. Okay, so this point O is said to be the center of gravity if the sum of principle of movements of all these particles about this point is equals to 0. That is, if I multiply M1 into R1 plus M2 into R2 plus M3 into R3 plus dash 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 up to Mn into Rn is equals to 0. Then this point O is said to be the center of gravity. So simply you will define it is an imaginary point that may lie within the body or sometime outside the body also, such that the sum of principle of movements of all the masses or the weights of which the body is made up of is algebraically 0. So that is what is meant by the center. So now I told you that the center of gravity, it may lie within the body or even outside the body also. So let us take some of the example when the center of gravity it lies within the body, like for a solid. Okay, like for a solid, the center of gravity obviously it lies at the center, but if you consider a rim or a ring just as a circle, like you consider a wheel of a bicycle, so in that case the center of gravity lies at its center, and which obviously does not lie on the body. Now for some of the regular objects, like if you have a quadrilateral, so the center of gravity of this quadrilateral lies wherever its diagonal intersect. For a square also it's the same, the center of gravity lies wherever its diagonal intersect. Now for a hollow cylinder, okay, so the hollow cylinder, so where is the center of gravity? The center of gravity lies at its axis. Okay, so axis means joining the two centers of the circle at the two ends. So if you join these two centers, that is the axis, so it lies at the midpoint of its axis. So in this, what is important is the definition of center of gravity and as well as the center of gravity of some of the objects. Now coming to the next topic about the circular motion. Now what is a circular motion? So if any object moves in a circular path, okay, suppose a racing track, a car is moving in a circular path. So if a body moves in a circular path, then that is said to be the circular motion. And in circular motion, the distance of the object from the center always remains the same. Now coming to the point, this circular motion is said to be the accelerated motion, in spite the body moving with a constant speed. Okay, so why is that so called? Because now if I consider a 3 point A, B and C. So at point A, the direction of the body is tangentially to the circle in which it's moving, and if I consider at B, again the direction is downward, again at C it will be like this. Okay, so we see that at every point what's happening, the direction is changing. Now though the speed remains same, but because of this change in direction, the velocity also changes, and we know that by definition whenever the velocity changes, it's said to be the acceleration. So thus we can say that a body moving in a circular path is said to be an accelerated motion. It's because of the change in direction of the body, which results in the change in velocity, and the change in velocity itself means a accelerated motion. Okay, so in this if you see that there are two kind of forces acting whenever a body moves in a circular path. Like if you tie a stone in a string and if you move it in a circular path. Okay, so what happens? As soon as you lift the stone flies outward or radially in that circle, and the string you are holding, it provides the necessary inward force. So the inward force is known as a centripetal force. So it's known as a centripetal force, and the outward acting force is known as a centrifugal. Okay, so centrifugal force. So it's very easy to differentiate between a centripetal and a centrifugal. The centripetal force is the one which is always directed towards the center of the circle, and centrifugal force is the one which is directed away from the center of the circle in which the body is revolving. And the centrifugal force is also known as a pseudo force, or it's also known as a virtual force, because it depends upon the frame in which the body is present. Like for example, if you think about a merry-go-round, when we are seated in a merry-go-round, so what happens, for us it appears that some force is trying to throw us away from the center of that merry-go-round. But if you are to observe the same thing from the ground or from outside the merry-go-round, then this force does not appear for you, or for the another person who is not in the same frame of reference. For him that force does not exist. So that's why it's known as a virtual or a pseudo force. So it's a very short chapter and easy as well. So I want you to go through this video and as well as through your textbook, and in the next virtual classes we shall discuss about some of the numericals and questions that are mentioned in your book. And if you have any problem, you are always free to contact me in my WhatsApp number. Thank you.